late posting. I almost forgot to post the meeting, but I know I'm going to do it, but sorry about that. Any questions at all?
I don't have any.
Okay. Well, in the meantime, we'll have the final Proctor U 22nd, right? 22nd, 23rd, which is Saturday and Sunday again next week. So I'm going to send out the details and then also post them on the Go View. Yep. All right. In the meantime, let's take a look at the assignment and where's the chapter this time? I thought we were going to do chapter 11, but no, chapter 10, I believe. Yeah, chapter 10 and assignment 11. Okay. So let's take a look what we have. So give me 1 second. Here we go. Where's my Excel? This is my Excel. Oh, there you go. Try to open too many stuff at the same time. All right, so here's the first question, first a problem of the assignment 11. And let me take a look at the actual statement. Okay. But it is about quality control. Okay. The chapter 9 was management of control. It's more of conceptual idea, how to manage the quality. But this chapter will provide us more technique and how to inspect, how to control, and how to sample those quality. So more of sampling and using statistical skills. More specifically, I think they called it as a control charts, okay? So that they can plot the samples on the chart, but you want to show upper limit, lower limits so that those sample means are within those ranges. So in order to do that, you need to find out, z-score, and you need to find out upper level, lower level, and plot them. So that's basically what the main technique in this chapter was talking about. And there are a few different charts. They have X bar chart. They talk about more of showing averages. And R chart does showing the range, meaning that the difference between the maximum and minimum value, so that you can show on the chart as well. And there are other charts that talk about P chart and C chart. P chart is more of defective or errors, and problems. So more of binary kind of type, whether you have error or not, you have you or failed or success, those kind of binary situation, we use P charts. Okay. So three main things we're going to do it in this assignment. X bar, R chart, and P chart, okay, as well as, those calculating statistical scores. So let's take a look. First one, And in terms of what they have, okay, they have automatic filling machine to fill the bottles of Coca-Cola, just cola. It's not Coca-Cola, but cola. So they want to find out okay, the machine output is approximately, okay. So they have mean of 1.0 liters and standard deviation 0.01 liter, so that we can determine upper and lower control limit, so that roughly 97% of sample means when process is control. Meaning that we're trying to find the upper limits and lower limits where all random samples are plotted that can be controlled. So that's something we want to determine. What's the upper level and lower limit, lower level. Okay. Let's take a look. Just a second. Though somebody's, all right, not. All right, so the information is given again. The mean is 1, the standard deviation is 0.01, sample size 25. Then these are the set of those samples, only 5 each, 3, 4, 6 each, 6 or 7 each, set A and set B. So which again, the idea is trying to set the upper limit and lower limit for 90% of level, 97% of level. So in this example, we're going to use standard deviation for sigma x bar, so that's pretty simple. What we do is just plug in, because this standard deviation is 0.01 and n is 25, it's just given, so just plug into just formula. This formula is given in the textbook. So this is not the one, but there you go. Okay. Something happened here. My slides are messed up a little bit. But anyway, this is from the textbook. So plug in those numbers into standard deviation formula, then we got 0.002. So again, we need to play with the z-score, and so each tail with 1.5. So if you go to normal table from the textbook or any references, you'll find the z-score that will be 2.17. So the reason we need the z-score is so that we can plug into upper control limit formula and lower control limit formula. Again, this is given in the textbook. Okay, so the x bar is given, which is 1, which is same as the mean, then plus z-score and the standard deviation. So I just kind of separate it a little bit, so make it a little bit complicated, but you can just do it at once, just calculating this by plug-in, so that we have an upper limit and lower limit. So upper limit is 1.00 and lower limit is 0.9957. Okay, those are the limits with 97% of level. Then, so we know the limits, and we want to plot our sample and see whether they are really within the plot, within the limits. Okay, so that's why we need to plot those 6 items. And what I did was just this one, you need to create it. It's not given, but I thought this is better than using probably template, the published template, because it's got a lot of stuff in the template. And if you just messed up one thing, it's sometimes hard to figure it out. So I just build it this way because it's all I did was just plug in from the set A. That's what I have here. And the upper limit score and lower limit score, which is we just calculated, and that's the mean is given. So then all we do is just highlight it and go to insert, chart. You can go to line, but I just thought I just go with this line chart, which is given, right? So click OK, and that's what's going to get. But to kind of give a exact point, you can just have a different chart type for this mean, the sample mean. So what you can do is probably go to design. I know it's kind of small up there, but toolbar, there's a change chart type so that we can change the, this is the sample mean, yeah, this guy. So we can change to the scatter so that, you know, we get exact points of those 6 of them, right? So some of them, 2 points are out of control, out of limit, right? Out of upper limit, and the other one is lower limit. So they are not in control, that we know, okay? So that's the plot with first set. The second set with the set B samples, different combination of samples this time. The same thing, I just organize this way for those samples. And we know the upper limit, lower limit, and then population mean, then plot just like that. And this time, all those 6 points are within the limits so that we know these are in control, this process in control. Meaning those set B is good, set A is not because a couple of points are out of limits. All right? So if you have any questions, let me know. Problem 2, let's see, this one. Yeah, this one is automobile wiper blade. And what was the exact wording for that? Replacing, okay, so the time yes.
Professor, I have a question. Are you by any chance recording?
Yes, I'm recording.
Okay, all right.
Yeah, sure, I'm going to post it.
Okay, thank you.
No problem. So this number, all right, these are the number minutes to replace automobile wiper blades. Okay, we have only 6 samples. So what's the total? Do we have a total number or population? 20 observations. Okay, we had a 20, but we have only 6 samples right now. And range is right there. Range is again, that's the maximum minus minimum. That's the range score, and the mean score. Okay. So here's what we're trying to. We're trying to use a now different equation to plot the averages with X bar chart, and same thing. Work with these ranges so that we can plot those ranges into our chart. Okay, so that's what we have. And what we're going to do is first step is find the mean of those means, the sample means, 6 of them, the divide by 6. Same thing, we have 6 ranges and add them up, divide by 6. Then you get mean scores. Okay, so that's the first step. Then I think a question, exact wording for question is, Okay, so we're going to just plot them. So make sure they are in control limit or not. And the other one is okay. They have another set this time. So let's take a look. So with that first set, what we're going to do is we need to find because this problem requires different set of where is it? Oh, there you go, X bar. Okay, and then there you go. So this is a finding upper limit, lower limit, and at the same time, we need to find the range. So that was just finding the averages, but this is for the range. For the range, we need the constants. See that A2, that's something they have it constant. It's more like weights, okay? So that you can use in this upper limit, lower limit formula. How are you going to find those constants? That's in the book actually. That's chapter 10. There's a page. Where's the page number? 436. Table number is 10.3. Actually, the direction tell you where to go. So you go to this page and you find this table. From there, you find this factors. Basically, those are the constant numbers. So because it's 20 sample size, that's why we have, and look for those numbers across 0.18, 0.41, 1.59. That's what we're going to use. So that goes to A2, D3, A4 based on the formula that we're going to use. So that's the same thing that we just coming from that table. So that from there, we're going to just plug into this formula again. This upper control limit, lower control limit, and plug in those as well as the mean and the X bar and R bar, which is means. Oops, yeah, I made a mistake. I mean this course. Okay. Those two scores, and gonna combine with constant we just found, then plug into this formula, and the lower limit formula is there, so we plug in, then we're going to find those value for the upper limit 0.716 and lower limit will be 0.185. So that's something we want to confirm, whether our samples are within that limit, then we are good. Otherwise, they are not in control, okay, in terms of the time taken replace the wipers. So the set we have is right there, those 6 samples that were given. Then upper limit that we just found from here. And then I'm talking about right here. Okay, that's the mean. And this is just the second set is for the range. So that's why they got different constant. We've just used the D3 and D4 accordingly. Okay. Again, for the average, then we just lined up with the upper limit and X bar, which is the mean score, and then lower limit. The reason I'm doing is so that I can plug into mean chart. Okay, so all I did was just highlight them, go to Insert tab, recommended charts, Then I just use the recommended chart of the line chart. Then I just click OK. Then you'll have all those lines. So to distinguish this our sample point, I just select that sample mean. Then I go to chart, change chart type. Then I change that to scatter chart so that, those line becomes now dots. So that's what I did. You don't have to do this way, but as long as it can be, identifiable, that's fine. I'm talking about those mean, sample mean spots. Same thing with the range. Okay, so I just organize this way so that I can plot the range just given, upper limit and lower limit, and R bar, which is the mean of those ranges. Then again, do the same thing and just plot from the recommended charts. And the conclusion is that you can see both of them are within the limit, right? So the first mean chart, all those sample means are within. Okay, same thing, the ranges are within, so it doesn't go over either top or bottom limit. So they are in control. All right. Problem 3. So what we have here this time. All right, so this looks like a credit cards. Now they are inspecting credit card errors and any kind of errors, typos, or calculation error on credit card statement. So that's what they're trying to inspect. So again, this time they're using another type of formula set, what they call P-chart. Okay, there you go. That's from the textbook, P-chart. Use a P-chart. So when observations are in two different categories, kind of binary status, good or bad, pass or fail, operate or don't operate, then we tend to use a P-chart to plot them, right? So here we go. The sample errors are given, okay? Then step A says find the proportion of those errors. So we just take that and take errors, actually. Take those errors, because sample they have is only 4 different samples, okay? 4 different types, okay? Even though they have 200 statements, okay? So they found 4 errors in first time, 2 errors second, 5 and 9. So we want to find the fraction or proportion of that error out of 200. So just what we need to do is just take 4 divided by 200, take 2 divided by 200, same thing, 5 divided by 200 and so forth. And you got, those proportions. All right. So since we're going to work with the proportions, the fractions, and then we're going to find the mean of those, okay, mean of those proportions. What are the mean of those 4 different numbers? Obviously, just take that and divide by 4, right? So that's what we got. That's the mean score of the sample, which is 0.025. Okay, and C is asking find mean and standard deviation of the sample. Okay, and the standard deviation the formula is given, all we do is just plug in, because we know the mean, we know the sample size, and so pretty much straightforward, right? So for the p bar, because we just found from here, remember the mean of those proportions. So that's what we're going to use for the p bar within this standard deviation. Okay. So I'm going to just show the formula here. Right here, that's the formula, which is the same thing as that, except the square root. Okay. I just separate it into within, inside of those square root. Then afterwards, I'm just use the Excel function, which is sqrt, so that I can have a square root over whatever I just found from B28. So that's kind of having two different steps, better than having one step for this formula. So ending up finding the standard deviation of 0.01104. I think we go for only 3 decimal places. Okay. All right, so we know the mean, we know the standard deviation now. Okay. Now, what's the D? Step D. Now we're going to use the, again, P-chart control limit. So P-chart control limit, upper control limit, lower control limit, which are given. What we're going to do is to just plug in again, okay, except the z-score. So we need to find the z-score, right? But this time the scenario is again 97%, 3% of those alpha level. Alpha is 3%, meaning that, those samples might be fall into those 3% only. And then we'll try to find out the upper limit and lower limit. Because we have tails 1.5, which is 0.015, then we go to a normal table and find 2.17, okay, because the probability to look for is just 1 minus 0.015. Okay, that's why this 0.985 must be the score that we need to work with in normal table. So if you go to normal table, which is a table B2 of any normal table from the textbook, you'll find 2.17. I think some people just use the Excel function, which is fine too. Okay. So we find the z-score, then we plug in, because other values are given. So there you go. So plug in for that upper limit and lower limit. Okay. So we find those upper control limit, lower control limit, just like that. Then we can show those into P-chart later on. Step E. What is this? What is the chance? Let's take a look at the actual wording for that. Step E. What alpha risk would the control limit of 0.047 and 0.003? So they're asking the other way around, right? So there was step D, they're giving alpha level. Then we find control limit. But this time they give you control limit, then we need to find alpha risk, alpha level. Okay. So again, we're going to use the formulas for upper level and lower level. Okay. which is right there, those two. Just plug in, then we find the other way around. We're going to find alpha risk. So, because if you plug in, then you find the z-score of 2. Then again, you go to normal table. Then you'll find 0.9772, and then you subtract from 1. Then you find 0.028, 0.228. Then you multiply by 2, and that's what the alpha label looks like, which is 4.56%. The chance of any random sample may go out of those control limit. Okay, so which is pretty low, 4.56, because that's what the question asks. Okay, you find the alpha label that might be go out of those control limits. All right. F and G, I think F is just plotting. Okay, so now we know all those values for upper limit and lower limit and proportion that we calculated from here, step A. Then we organize the table just like that. Mean, we just found the mean, sample mean. Was it sample mean or population mean? That's the sample mean. Okay. So we again just plot, insert, recommended chart, where's the line? So I use that just like before. Then I separated that proportion. That's what we're working with, and make sure they are within or outside of limits. Looks like they're all within the limits, so they are okay. And what is the last one? Step G. G is asking, is it G or H? Okay, G. There you go, G. It's asking, suppose the long-term fraction defective process is 2%. What are the value of mean and standard deviation of sampling distribution? Okay. All right, so we plug into standard deviation, okay, because the proportion of the defective process is 2%, okay? So plug in those P bar, okay, right there. Then, go through that. Then I just also did square root of the whatever I had from previous step. Then I found that to be 0.0098. Is that what we're gonna find? Mean and standard deviation. Oops. So that's the standard deviation, right? Mean is already, we know the mean, but standard deviation, by plug-in, we've just found it. Okay. All right, and then, what's the last one? Okay, with step G, we're gonna plot some reason I think I didn't do H somehow. I think we're going to just have a plus minus 2 of that. Let's see. Of that control limit. Where's our control limit for that? Okay. So that part will come up with okay, so we're going to use this value and you multiply by 2. Well, G part, not sure what exactly they're asking for. So I think I'm gonna take a look this one later. But H, I think I skipped that part. What was the H? Is this H? F. I'm sorry, F. Okay. So showing them in P chart, I think I skipped. Did I skip that or did I show them? I think I showed them. Okay, that's fine. So the last step, I was not sure what exactly this is asking. So I'm going to just come back with this. Okay. So and my guess is we need to multiply by 2 because we're talking about 2 sigma control limit. Okay. So just 2 times of those standard deviation. Then you have the upper level and lower level. New upper level, new lower level. Okay. I think that's what they're asking. All right. Any questions?
For that last one that is not complete,
Yeah.
H, and I'm seeing that you're trying to figure out how to complete the question. How are we going to do it, or should we just, I don't know,
well, you try
give it our best shot?
Yeah, give our best shot. Yeah, I'll
Okay.
try to update as soon as possible.
Okay.
Yeah, I'm going to post in the announcement. Hopefully, I can do it tonight, but try your best. Okay. Even though you made a mistake on, just fraction of scores. So.
Okay. A question I have, the homework says to use the publisher's Excel template.
Oh, okay. Yeah.
To me, it's very confusing.
Yeah,
Can we just use Excel on our own?
Right. That I thought was a pretty simple to use, but it turns out I tried it. It's not that easy.
No, it's not.
No, it's not. So just use your own Excel. That's fine.
Okay. Perfect. Yeah. Thank you.
No problem. Any other questions? And in terms of the final, and I'm gonna send out details, but my thinking is chapter 7, 8, 9, and 10 that we just did it, but I don't think we're gonna do a lot with this chapter. Just probably just simple questions like a plot, X bar or R chart, those kind.
If we have to, if we have chapter 10 as part of the final and we're looking for a Z-score, are you going to post a link to a
Yeah,
distribution table?
All those necessary data set or formula will be available. I'm going to just post it.
Okay.
Yeah.
I know usually in like statistics, if we have to find a z-score, they post the distribution table.
Of course. Yeah.
Okay.
And otherwise, I mean, that's chapter 10 and chapter 7, 8, 9. So chapter 7 was work design, I believe, and, work measurement with the precision and confidence level. There was some of those statistical stuff like this one, work cycle and sampling user. Remember using random number table, you find the time that you're going to give into some work. That's the chapter 7. And chapter 8 was location planning. Okay, remember those profit and costs, variable costs, fixed costs, and you also have a revenue, and just manipulating some of those formulas and equations. So that was chapter 8. Chapter 9, management of quality. So more of check sheets and Pareto chart, run chart, which was simpler than other chapters. Then chapter 10 we just talk about. Okay. So that's kind of summary of those 4 chapters. I'm talking about the problem solving questions. All right, any questions? All right.
Nope. Good.
Okay. Okay. Thank you, guys. We'll see you next time.
Thank you.
Thank you.
Bye-bye.